The belief that bigger homes meant better survival on the frontier was wrong, and in some cases, it was fatal. In the last year of the 18th century, wealthy settlers in the Rocky Mountains built towering homes with ceilings reaching 30 feet high, believing they had recreated the strength and elegance of European architecture. What they actually built was structures that worked directly against the laws of survival. If heat rises, why would anyone design a home where warmth could never reach them? Why did these massive fireplaces burn endlessly, yet fail to keep people alive? And the more unsettling question, how did something so obviously flawed become a symbol of success? Because what happened inside those homes wasn't just inefficient, it was lethal. Deep in the Rocky Mountains, survival wasn't about comfort, it was about control. Control of heat, control of shelter, control of the environment trying to kill you. Water froze, wind cut through wood, temperatures dropped below zero without warning. And in that environment, heat wasn't a luxury. It was the only thing keeping you alive. Most early settlers understood this immediately. They built low, tight, close to the ground, structures designed to trap warmth where it mattered around the human body. But wealth changed behavior. Those who found success through gold, land, or trade wanted more than survival. They wanted proof. Proof that they had conquered the wilderness. And the fastest way to show that wasn't efficiency, it was scale. They built upward. Massive timber frames, wide open interiors, vaulted ceilings stretching 20, sometimes 30 feet above the floor. Standing inside these structures during the summer, the effect was undeniable. Light poured in, air moved freely. The space felt powerful. It looked like control, but winter didn't care how it looked. The moment temperatures dropped, the entire structure turned against its occupants. Because heat doesn't behave the way most people assume. It doesn't stay where you need it. It moves. When a fire burns, it heats the surrounding air. That air expands, becomes lighter, and begins to rise. It rises until it hits a barrier. In a small cabin, that barrier is close. The heat spreads, reflects, and settles back down into the living space. But in a vaulted structure, that barrier is far above. Too far. The heat rise sand keeps rising. It gathers in the ceiling, building into a dense layer of warmth that never returns. And below it, where people actually live, the air remains cold. The difference isn't small. In extreme conditions, temperatures near the ceiling could reach comfortable levels, while the floor remained near freezing. A vertical split, warmth above, cold below, and no natural way to reverse it. That space became what survival engineers now call a thermal dead zone, a region where energy exists but cannot be used. Settlers responded the only way they could. They burned more wood, more fuel, larger fires, longer burn times. But it didn't solve the problem. It made it worse. The stronger the fire, the faster the heat escaped upward. The harder they tried to survive, the more efficiently the system worked against them. And the design had another flaw that wasn't immediately visible. The structure itself couldn't contain the heat. These buildings were made from massive timber, often cut and assembled quickly. As the wood dried, it shifted, warped, opened small gaps between beams. Near the top of these tall structures, those gaps multiplied. And that's where the heat was. Not near the people, not near the fire. At the very top, where it slowly leaked out into the freezing night. At the same time, something else was happening below. As warm air escaped upward, it created a pressure imbalance. The house began pulling in cold air from outside, through cracks in the floor, under doors. Between boards, cold air rushed inward, hugging the ground, moving horizontally across the living space, cutting through clothing, through blankets, through skin. The inhabitants weren't just losing heat. They were being actively stripped of it. Warm air escaping above, freezing air replacing it below. A continuous exchange. An invisible system working perfecta, just not in their favor. And then came the windows. Large, tall, impressive, designed to flood the room with light. But in winter, those windows became something else. Glass in the 19th century had almost no insulation value. It didn't block cold, it transmitted it. Warm air that reached the walls cooled instantly when it touched the glass. It became dense, heavy, and dropped, falling back into the living space like a silent wave of cold air. This created a circulation loop. Warm air rises, cools at the edges, falls, then gets reheated and rises again. Except the reheating never fully happened because the heat was trapped above. The cycle continued, over and over, removing what little warmth remained near the floor. And then there was a final danger zone that couldn't be seen or felt: carbon monoxide. In a properly functioning system, smoke and gases rise and exit through the chimney, but these environments disrupted airflow. The extreme height, the drafts, the unstable pressure reel of it interfered with the chimney's ability to pull gases upward. Sometimes, instead of escaping, those gases lingered, collected, settled into low areas where people slept, which meant the same structure that failed to keep them warm could also quietly suffocate them, all while the fire continued to burn, all while heat filled the ceiling above them. The failure wasn't just architectural, it was psychological, because the design wasn't based on survival, it was based on image, on memory, on the idea that success should look a certain way. That space meant power, that height meant control. But the environment didn't respond to image, it responded to physics, and physics doesn't negotiate. Indigenous structures, trapper shelters, and low-profile lodges all followed a different logic. They stayed low, they minimized volume, they trapped heat where it mattered. They worked with the environment, not against it. And they survived. The vaulted structures didn't, not without constant struggle, not without excessive fuel, not without risk. And yet the design didn't disappear, it evolved. Today, those same high ceilings exist in modern homes. Large open great rooms, expansive vertical space designed to impress. And the same problem still exists. Heat rises. Ceiling fans push it back down. HVAC systems compensate. Energy consumption increases. Modern technology doesn't eliminate the flaw. It masks it. It fights it, constantly, which raises a question that never fully gets asked. If a design requires continuous effort just to remain livable, was it ever truly functional to begin with? Because the frontier already answered that question. Not with theory, with consequence. These structures didn't fail slowly. They failed in winter. They failed at night. They failed when survival mattered most. And the lesson they left behind wasn't subtle. It was absolute. Architecture that ignores physics doesn't just perform poorly. It becomes dangerous. So the real question isn't why these structures failed. It's why we're still building versions of them today. Because if the same design still requires us to fight the same natural forces, then maybe the problem was never solved, only covered. And if that's true, then how many modern systems are still working against us, while we assume they are working for us?